In this presentation, we'll show how to use the curve function to plot a mathematical function in R. Our first example of a function will be the logistic function, or one version of the logistic function, which is an S-shaped curve shown here. It will have three parameters. The first parameter, x0, will determine where the middle of the S occurs on the horizontal axis. The parameter L will show how high the S goes, and K will determine how quickly it goes from 0 to L. This version of the logistic function has a simple numerator, just L, and then the denominator is 1 plus an exponential function, and then the exponential function depends on the parameters k, x0, and our variable x. Here we're showing the beginning of our R script, and we are assigning values to the parameters. So in lines 5, 6, and 7, we have L equals 2.5, K equals 1.25, and X0 equals 3.4. These are just numerical values assigned to the parameters for the sake of an example. So here on lines 12 to 17, we are showing R's curve method that we are using to plot this function. In this case, we are using 5 arguments for the function. So the first argument is the function we are plotting. So curve, note, is a method, and it has parentheses beginning up there after the curve, open parenthesis, and that parenthesis is closed down on 17. And then we have the function, which also has a number of parentheses, so it's confusing in all the parentheses. But the function, the logistic function, was, the numerator was simple, just L divided by. And then there was 1 plus an exponential in the denominator. So in order to get the addition to be done before the division, we need parentheses around 1 plus the exponential. Then in computers, the exponential is a function, so it's exp, and the exponential function had its set of parentheses. And then the argument of the exponential was minus k times the quantity x minus x0, and the x minus x0 was in parentheses. So that's a lot of parentheses, but some keeping track. Okay, so now the second argument, we need a domain that we're going to plot over, and so the second argument is from, and this is the value of the variable x that we are starting from. That's one thing to note, is that curve always wants the variable to be called x. So then it's implied, we don't have to say in 13 that that we're going from x equals minus 21, because it always wants the variable to be x, so it's implied then it's x. And so then in 13 we can just say from equal minus 2.1. The third argument was 2, so we're going to go to a 6.7. The fourth argument was just a color, so col equals blue. We decided to make our curve blue. And the argument on 16 was LWD, the line width, and so we decided to make it 2 to make it a little bit thicker than the normal curve that we would draw if we didn't specify that parameter. And again, we have 5 arguments here, so we are expecting 4 commas, and we can see those commas, and then we've added comments to explain all of our various arguments here. And so here is the result, the plot. So the result of the curve function is a plot, and we see it's showing us this S shape that we expect for the logistic function. Now I want to show you another possible argument to the curve function, the add argument. So I'm going to draw a second logistic function, but I'm going to include it in the same plot as the first one. So from line 20 to 24, I'm just defining a new set of parameters, and then in lines 29 to 35, I'm showing the curve function, and I'm adding one more argument at the end, add equals true, and that means to take whatever plot result you might already have and then add this curve to it. So now we have 6 arguments in the curve method, so we're expecting 5 commas, and the new argument is to add this to the result that we already had plotted. And here's the result showing the 2 logistic curves with different parameters. I'm just going to show a second example, and this is going to be what's called a Bezier Quadratic. So it's shown down there in the formula. B of t is equal to 1 minus t squared times some p0 plus 2 times 1 minus t times p1 plus t squared times p2, and this is on a range from 0 to 1. So t is the variable, and p0, p1, and p2 are the parameters. So here it is shown as an R program, and so from lines 5, 6, and 7, we are assigning our parameters. So I made p0 3.2 and p1 minus 1.2 and p2 1.4, just some arbitrary numbers for the sake of an example. Then in 14 through 19, we are doing the curve method. I have changed all the x's for t's because curve wants the variable to be an x, so whatever your variable is must be replaced by x. That's important that you remember that. And then the other thing to note here is that many times when you see somewhere in the literature you see some function, multiplication will be implied. So 2 things next to each other, it's implied that they are multiplied. But when you're doing things in a programming language like R, it wants an explicit multiplication, so you must add the asterisk. So the function was parentheses 1 minus x caret 2 to square it. Again, I replaced the t with an x, and then I have to say asterisk p0. Previously the multiplication was implied, but I must make it explicit, and then plus 2 asterisk parenthesis 1 minus x close parenthesis asterisk x asterisk p1. Again, all multiplications must be explicit, plus x caret 2 star, I often just call it star instead of asterisk, p2. So that was the function. The variable must be x, and multiplications must be explicit. I'm going from 0 to 1. I'm going to make it green, and I'm going to make it very thick, LWD equals 3. Now here we see the result in the plot region. Now we know from previous experience that we could use an argument main equals and give this a title, an overall title, and it's been given a default y-axis label, but we could use the ylab argument and write our own y-axis label if we didn't like what was there by default. Now your turn. Write an R program that shows the parabola that a projectile will follow. So the function we're going to plot is y as a function of t is y0 plus v0 times t plus g t squared divided by 2. So y0 is a parameter, we'll choose a value of 0. v0 is a parameter, we'll choose a value of 15. G is a parameter, we'll choose a value of minus 9.8, and let's plot it from a domain starting at t equals 0 to t equals 3.5. Remember, in R, it wants the variable to be called x and not t.